Hello friends, this is Samir. I am going to present you some important aspect related to structural impact analysis. Uh, I try to simulate the structural impact that based on low velocity impact, high velocity, and different energy levels in the couple of lectures in the past. So currently I'm going to include some uh, similar aspect which is somehow different from that. So in the flight, an aircraft encounters a number of impacts, which includes the ice impact or hill impact, and also the aircraft encounter with bird impact. So during the time when an aircraft face bird impact or kind of ice impact, so a number of damage will happen on the structure. And at the same time, the behavior of the impactor also differ from the rigid impactor that we have discussed in the last lectures. So what will happen when the aircraft structure subject to this external bird impact during either takeoff or during landing or in some high altitude also such thing may happen because the huge birds like vulture, they fly at the altitude of aircraft cruising altitude sometimes because that is recorded. Some flights have faced such problem. So what will happen in the structure when the structure is facing such an impact, and what is happening to the bird itself? So that is the situation which we are going to simulate. So how we can simulate this? I can start it from the very beginning. We can start Abacus from the very beginning. So we'll go to creating part module. Okay. Now this is for the impact analysis of isotropic plate. Like aluminum is one of the structural components for the aircraft. So the impact with aluminum plate is also the part of this. So what will happen? So we'll create the model of plate as aluminum plate. Okay, this for a simple analysis case, I used a conventional shell element of S4R element. So a square shape of aluminum plate is taken, which is 100 by 100 dimension. And then material property of aluminum is given. That aluminum property is for the plate, which is density 2.77 or 2,770 kilogram per meter cube density is given, and the elastic property of aluminum is given here. That is 73100 megapascal. That means 73.1 gigapascal is considered, and 0.33 Poisson ratio. So this is actually in megapascal. Okay. Another property is the elastic property. No, the plastic property of aluminum. I simply used the yield stress 170 for undamaged or inelastic region, and for the 1% plastic strain 340. I used it as simple model. So this is the aluminum properties defined here. And another model we need is the bird model. So the bird is considered as deformable 3D shaped object. Okay, simply a cylindrical shape I consider here, but most of the researchers they use some spherical shaped bird with some end cap. Anyway, that is also very simple, no problem. That so let's see a simple cylinder shape bird. A bird is modeled with a cylinder shape, and the material property of bird is given as edit. So this density of bird is 9.4. That is 9,000, no, 940, that which is less than the density of water, which is considered. Okay, the density of bird is, because bird is considered as modeled as a combination of air and water combination. So density of air is less than water, so the density is 9.4. E11 means no, it should be E9. Sorry, this should be 9. Because what we are using here is ton per millimeter cube. Ton per millimeter cube means we can take it as 940 kilogram per meter cube, which is equal to 9.4 times 10 to the power of minus 9 tons per millimeter cube. So the unit is here, it is ton per millimeter cube. So that is 9.4 E9. And the equation of state is given as C naught is from some experimental papers. I took 1,450 meter per second C naught and S0 gamma 0, and the method here used is the UC USUP method. Okay, that is the most common method that people can use for this modeling, and viscosity of a very small amount, that 1 times 10 to the power of 9 minus 9. So that is the viscosity, dynamic viscosity is considered. So these three material properties are considered for the bird model. And then the bird model is considered as a homogeneous solid, which is considered a homogeneous solid, and the material properties assigned to the bird. Again, the plate is considered as a continuum shell, so that we consider the plate aluminum plate, and that the thickness of 3.5 is given for the plate. Okay, that is plate material is selected. So this is the way how we can assign material property. And then the next step is assembling the two instances. The bird instance as well as the plate instance are assembled in this module. That assembly module helps us to assemble them. Then after, mesh is created for each of the parts are meshed. Okay, the plate also meshed, the bird also meshed with an appropriate type of mesh. And here, while we are meshing, we consider all the nodes as an important point for us, so that we set a mesh. We set nodes for this, which nodes are considered as the particle. We use them as a particle. So nodes are considered then once we, while we are assigning mesh, we assign the element type. Okay, the element type assigned for this is 3D explicit. What we are performing is explicit analysis. So 3D explicit analysis. On that, one important thing that we must consider here is, in the case of the analysis of bird impact or um, what we call this smooth particle hydrodynamic case, we select the conversion to particle is here, it is yes. And then the kernel, we can use cubic or quadratic, most usually it's cubic. And the time threshold is at 0, that is the instance. So this should be selected, okay, for the bed. And the plate is also appropriately assigned with material property, okay, that is explicit, that is shell element, so that it is S4R. That is a 4-noded double curved thin or thick shell, radius integration hourglass control, finite membrane selected. Okay, so this is the plate model. Okay, then what is next? The next one is assigning load. Okay, we assign the boundary of the plate as rigid boundary so that encountered boundary condition is considered for the plate, because this part of the plate is which is taken from the structure of the aircraft. Either it can be the wing or it can be from the part of fuselage that aircraft can hit the structure, so that that is considered as a rigid on the structure, so that encountered boundary conditions selected. And the predefined velocity field, which is most of the time the aircraft and the relative velocity that the moving bird maybe fly in hundreds of meters per second, so that I consider here the velocity as 14.5 meter per second, that it is not very hyper, but a moderate velocity of 14.5 meter per second, or 14,500 millimeter per second is considered here. Okay, and the mass of the bird, most of the time, 1.8 kilogram to 5 kilogram of mass of the bird is considered in most simulations, so that the mass of the impactor or the mass of the bird is considered 1.8 kg. Okay, so that is considered. And the interaction is, we used a general interaction that general interaction or general contact is used. Okay, and finally the time step is given here is 0.006 second, or that is 6 millisecond. Still it is too much high, because this is a kind of high speed velocity, so that the time of the moment of impact is very less than this, but I used 0.06 for simple analysis. Okay, so that explicit dynamic analysis is considered. Okay, so this is the model made for bird impact. So, and then the job is run using this is one of the completed job, because this one in my laptop it takes long time, because very dense mesh is used for to generate a number of particles on the bird, because that bird body is considered as a particle. So let's see the result of this this model. So this is the model that I created for bird impact. So what it seems like, let's see together. Yeah, here when the bird hits the structure, the body of bird immediately splashes over the surface of the structure. Okay, so that's why it is here. I can show you one by one. Okay, how it step by step, because we have 20 frames. This is the first frame, second frame, third, fourth, fifth, sixth, seventh, eighth, 9, 10. You can see how the structure also responds. At the very beginning, the bird comes with full size, and after it hits the structure, immediately the bird will splash like as water on the surface of the body. So this damage is not localized damage, because uh, it goes over other wide dimension of the structure. It covers wide dimension of structure, not only the local. It creates not only the local damage, but damage in the some far regions also. Okay, so this is the situation of impacting. More clearly, let's see on U profile. This will show us more better. Um, yeah, it is splashing over the surface again. This is how it is spreading over the surface of structure. Even we can see the particles here. We can zoom them, this thing. We can zoom and we can see how it is distributing. Okay. So this is a simulation of bird impact to aircraft structure. This impact happen most of the time in the area where an aircraft is taking off, because there are a number of birds around the airlines which are uh, impacting with the flying aircraft, or at the time when it is landing. And sometimes it happens in some high altitudes also. So this is what I'm going to show you. Let me simulate it. Just see it, the simulation. It gives you time to observe the situation of impact. So once you understand this, let me give you some brief lectures with the history of this happening. This is enough for the purpose of demonstration. Okay, so let me go and share another slide. Let me share the slide. So let's see the slide. Okay. So software impact analysis using Abacus is our topic. So this is an interesting topic. I'm quite sure all of you like it later at the end of final, because we may have many parts of this thing. Okay, this is not the only thing. So our presentation outline contains bird strike to aerospace vehicles, location of bird strike events, uh, the countermeasures, the modeling bird strike, finite element modeling of bird strike. Okay, um, equation of state for modeling, and modeling for bird strike with isotropic plate, modeling for bird strike with composite plates. These are the topics. So bird strike is a common happening and can be significantly harm the aircraft structure, and it can threat to aircraft safety. For small aircraft, significant damage may happen, and the structure will damage during the impact. So especially jet engine ones are very vulnerable to the loss of thrust, which can follow the ignition of the bird into uh, engineer intakes. So what you can see here are a number of the flock of birds are there. Okay, so which hits the structure while the aircraft is in takeoff, or in the case of landing. So that can cause a number of distraction to the aircraft structure. So bird strike, sometimes we call it as bird ingestion for the engine case. When the bird is ingested into the engine, then we call it as bird ingestion. And bird hit, where it hits the structure, the canopies, the wing, the fuselage of aircraft. Okay, so during that time we call it as bird hit, or a bird aircraft strike hazard, or in abbreviated form, BASH, is a collision between an airborne animals. These airborne animals, usually the bird or the bat, and a moving vehicle, yeah, usually an aircraft. Okay, so the term is also used for bird days resulting from the collision with structures such as power lines, towers, and wind turbines. Actually, birds can also collide with the power lines. Actually, not collide, but they yeah, it happened even with the collision. Again, they collide with the towers and with the wind turbines, which rotating wind turbines, and can be faced with days. So this is an example of bird strike on the aircraft. This is the happening, okay, which is taken from Wikipedia. Okay, so bird strikes are significant threat to flight safety and have caused a number of accidents with human casualties. There are over 13,000 bird strikes annually in the USA alone. This is a very large number. Okay, in one country alone, in USA, 13,000 bird strike happen means that is a very large number, and we can observe what kind of accident will happen during this time. However, the number of major accident, including in the civilian aircraft, quite lower, and it has been estimated that there is only about one accident resulting in human deaths from billions of flight hours. Okay, that is something but still there is a great number of losses on that. The majority of bird strikes, which accounts 65%, cause little damage to the aircraft. However, the collision is usually fatal to the birds involved. So the most common birds which are in the runways and on the higher altitude, especially this skylark is the one near to the aircraft on during landing and the takeoff. But the one which causes damage at very high altitude are those vulture and other birds like this. Okay, these are the type of birds which most usually face strike with aircraft. Common locations of aircraft body which face bird strikes are the windshield of canopy, that is the canopy or the windshields, the nose, the nose cones of the aircraft, again the engines, okay, which sucks the air for, and also the wing, and the fuselage also. Most of the fuselage is exposed for striking of bird. So that these are the most common locations of aircraft that striking of bird happen. So most accidents occur when a bird collides with a windscreen or is sucked into the engine of the jet aircraft. Okay. So this causes annual damage that have been estimated at 400 million US dollar, along and up to 1.2 billion to commercial aircraft wildlife. Okay, this is the loss that the world faces with bird strikes. In addition to property damage, collisions between man-made structures and the conveyance and birds is contributed factor, among many others, to the worldwide decline of many avian species. The International Civil Aviation Organization, ICAO, received 65,139 bird strike reports for 2011 to 2014. And the Federal Aviation Authority, FAA, counted 177,269 wildlife strike reports on civil aviation between 1992 to 2015. So growing 8% in 7 years from 2019 to 2015, which is bird strike accounted for 97%. So bird strike happen most often during takeoff or during landing or during in low altitude flight. Okay. However, bird strike have also been reported at higher altitudes. Some as 6 to 9,000 meters, which is 20,000 to 30,000 feet above the ground, which is the recorded one is a bare-headed goose have been seen flying as high as 10,175 meters, which is 3,383 feet, which is almost the very high altitude. An aircraft over the Ivory Coast collided with Ruppel's vulture at an altitude of 11,300 meters, which is 37,010 feet, the current record aviation height. So this height is the safe altitude for aircraft that most pilots are flying with autopilot zone, because that is a autopilot cruising altitude for most aircrafts, like even the recent Boeing families are also flying on this altitude. So this is happened, okay? So the majority of bird collisions occur near or at the airport, which is the common locations are airport. According to the civil aviation, 90% of bird strike happen during landing and takeoff near to the uh, airports. So this is the situation during takeoff. We can see a number of birds which are coming in contact with the aircraft which is taking off at the moment it's taking off. And this bird is sucked into the engine. At the same time, they collide with the structure. And if a number of collision happen, then the aircraft body, some of the engines will malfunction and can cause a very high disaster. Okay, that is what. According to the Federal Aviation Authority, the wildlife hazard management manual for 2005, less than 8% of strike occur above 100 meters, which is 3,000 feet. The point of impact is usually any forward-facing edge. As we have seen here, most of forward-facing edges are encountered with impact. Okay. Like the wings, the wing leading edge, the nose cones, the jet engine cowling, or engine inlets, and the front shield canopies. Okay, those things are facing with impact. Okay, jet engine ignition is extremely serious due to rotation speed of the engine fan and the engine design. As the bird strikes the fan blade, that the blade can displace into another blade, which means it locks another blade and which can cause immediately destruction to the blades there. Okay, which is a cascading failure will happen. So jet engines are particularly vulnerable during the takeoff phase when the engine is turning at a very high speed and the plane is at low altitude where the birds are more commonly found. The force of impact on the aircraft depends on the weight of the animal and the speed of difference and duration at the point of impact. So the energy impact increase with the square of the speed difference. Okay, that is high speed impact as the jet aircraft can cause considerable damage and even catastrophic failure to the vehicle. So the energy of 5 kg bird, that means very big bird, which accounts 5 kilograms. So moving at a relative velocity of 275 kilometers per hour, which is 171 mile per hour approximately, equals the energy of 10 kilogram, which is equivalent to 220 pounds weight, dropped from a height of 50 meters, that means 49 feet. Okay. So how it is, how we can relate 5 kg moving relatively 275 kilometers per hour is equivalent with dropping or just throwing 100 kilogram object from 50 meters height on the structure. So that is very huge amount of damage. That penetration or local damage will happen. Complete destruction of the structure may happen. Okay, so however, according to the Federal Aviation Authority, only 15% of the strike or 11% of the strike, according to the ICAO, actually results in damage to the aircraft. So bird strikes can damage vehicle components or it can injure passengers. The flocks of birds are especially dangerous and can lead to multiple strikes with corresponding damage. And depending on the damage, aircraft at lower altitude or during the takeoff or landing often cannot recover in time. Okay, so US Airways flight number 1549 is a classical example for this. That recovering the aircraft after impact is very difficult job for the pilots. In 1909, a double bird strike involving Canada Goose and an Airbus A320, which is the pilot who is flying with this aircraft is Captain Chelsea Slenberg, was forced to make an emergency landing on the Hudson River in the New York after the strike with the Goose. The engine of the Airbus A320 used on the flight were torn apart by multiple bird strikes at lower altitude. So there was no time to make safe landing at an airport. That it forced them to land on water. Okay, so water landing in the Hudson River happened during this flight. Okay, so we can observe here the passengers stand on the wings of USA Airways. Plane as a ferry pulls up to it is after it landed in the Hudson River. So this image is taken from the Reuters. So what are the countermeasures? What can the authorities which concerns about this issue will do? One is three approaches are considered. One is the vehicle can be designed to be more bird resistant. That is one approach. The second approach is the bird can be moved out of the way of the vehicle, means removing birds near to the flight area. That is the second approach. And another one is the vehicle can be moved out of the way of the birds. These are the proposed approach. Okay, so when we say the vehicle can be moved out of the way of the bird, or the bird moved out of the way of the vehicle, means there must be some mechanisms which can adjust the vehicle whenever the birds come, that can push the birds away from the vehicle's path, or the vehicle to divert its path. This kind of mechanisms are highly required, and also more bird resistant aircraft structures are required. Another vehicle design, also another thing. The design of vehicle, for example, if the vehicle is designed with some propelling or some bird propelling in some far distance, which produces some wave whenever the birds are sensed on the path, if there is some mechanism which can push the birds away. This kind of mechanism may be required on the vehicle design, or also wildlife management, that lethal or non-lethal techniques must be adapted, or habitat manipulation techniques, and also visual repellents and the auditory repellents like blasting pyrotechnics or producing some sound producing equipment near to the airport. These things are some kind of counterparts for the this happening. So in the next, so what happened when the birds hit the plane in mid-air? This is kind of happening. We can see a number of birds here. Birds pose a serious risk to airlines and have forced emergency landing, and in some cases even a crash. So the Ryanair flight to Spain was forced to return to Manchester Airport after a bird collided with the engine of the plane. This is as we have seen the first case here, that is US Airways flight 1549, and also this is another report that Ryanair flight to Spain, also another situation which is registered. So it is returned to Manchester Airport after a bird collide with engine of the plane. According to the budget airline, there was no danger to the passengers or aircraft at any time. But this is far from the first time. A bird has struck a plane, and the consequence can sometimes be very serious. So this is what. So how we can model bird? So modeling bird impact will be our next topic. So I'll stop it here. This is sufficient for today.